Okay, so in this video we are going to be solving the following problem with singly linked lists, and that is specifically to determine if the linked list that we're given is a palindrome. And more specifically, are the data elements stored at the nodes in the linked list, does that form a palindrome with respect to how the list is formed? So for instance, let's just talk about what a palindrome is if you don't know what that is. A palindrome is simply a word that is spelled the same front to back. So race car is spelled the same from front to, and it's also spelled the same going backwards as well. So radar is another palindrome. Some non-palindromes would be words that are not spelled the same forwards and backwards. Test, ABC, hello, etc. It's a lot more non-palindromes you can probably think of. So what I've done now is I've constructed two linked lists where the first list that we have here is the palindrome radar. So the data nodes at each of the elements that I have here correspond to the data elements RADAR, which the list is radar. I have another linked list here that I've defined as a non-palindrome with just the nodes with data elements ABC. So basically what we're going to be doing is we're going to be using these two lists, writing our function to determine if these lists are palindromes, and hopefully we should see true for the first list and false for the second list. So I've also gone ahead and called the isPalindrome function that we will be filling out in this video for both of these lists. And what we're going to do is we're actually going to take a look at a few different methods of solving this problem. So there's not just, and even this video is not limited to only the ways that we'll cover here. There's plenty of other ways you can solve this problem as well. So let's go up and actually try to solve this problem. So let's put in a comment that says method 1. So the first method that we're going to do is we're going to start off at the front of the linked list. And we're going to move along the list, and all the while we're going to be keeping track of the data element that we encounter. So we're going to be storing that into a string variable in Python, and then we're just going to check whether or not the string variable can be read both the same forward and backward. And we're just going to be doing that check using a very simple one line in Python. So let's go ahead and write that up, and then I'll explain as I go. So first what we're going to do is we're going to define a string which will initially set equal to the empty string. This will eventually store the string contained in the entire list, but initially it's empty. And then we're going to define a node pointer which will initially be equal to the head of the list. We'll be moving this pointer across each node as we progress throughout the list, and then we'll be checking the data element at each node in the list. So what we're going to do is we're going to say while p, so essentially while p is not null, we're going to move our way through the list. So we're going to say p is equal to p.next. So this will move us from one node to the next node until we hit the null terminating node in this list. Before we do that though, what we want to do is we want to continually concatenate onto the string s the data elements stored at each node we encounter. So the way that we can do that is we can say s plus equal p.data. So essentially what this is going to do is we start off on the head node, we read it, we say, okay, what is the data element that's stored at the head node? Okay, it's r. Concatenate that onto the string s, which initially is empty, so string s stores r. We move on to the next node with this line right here. This p is equal to p.next, and then we move on to the next one. We encounter a as the data element there. We concatenate that onto s, so now we have r a. Move on to the next node, and so on until we get to the end of the list. So then basically all we need to do at that point is the string s should contain the entire string for the list. All we need to do now is check if the string can be read forwards and backwards in the same way. So all we really need to do is return s equal to the reverse of s. So basically I'm just checking if this equality is true. So if the string s is equal to the reversal of the string s, this open square brackets : -1 is just a shorthand of Python for reversing the string. So if the reversal of the string is equal to the string itself, then we know that we have a palindrome, and we return true in that case. So let's go ahead and make sure that this method works. We'll go ahead and save this and then run it. So let's say Python linked list. And so indeed we have true, and we also have false. So true for radar, false for ABC. Okay, so I'm going to go ahead and just comment this method out now because we are going to consider another method for solving this problem. So the next method is a little bit different than method 1, but it's kind of got a similar spirit to it. So method 2 is going to involve the use of a stack. And we're not going to actually make use of a stack per se, but the idea is the same. We're going to make use specifically of Python list, but we're going to be using the append function and also the pop function, and both of those operations are similar to what you would see in the stack data structure with push and pop. So specifically what we'll be doing in this method is we'll be moving along just like we did in method 1 from node to node to node, and all the while, instead of concatenating onto a string, what we're going to be doing is we're going to push onto the stack. So as we move through the list, we're going to continually push the data element onto the stack. And then what we're going to do is we're going to iterate through once more, and then we're going to check whether or not the popped element is equal to the element that we're encountering on our second iteration of the loop. So let's go ahead and write that out, and I'll keep explaining it as I write it out here. So method 2. So in this case, what we can do is we can have, let's say, again, p is equal to self.head. So this is the pointer that will initially be equal to the head of the list. We'll set s equal to an empty list. So this is kind of our stack-like object, which we're initializing to an empty list in this case. And then we're going to say while p, so again, moving on through the list, we're going to essentially push or append the data element of the node that we're on. So we're going to append p.data onto the list, and then what we're going to do is move along in the linked list. So we're going to say p is equal to p.next. So then what we're going to do is we're going to once again iterate through the linked list. This time we're going to pop off the element of the stack object, essentially s, and we're going to check whether or not that's equal to the data stored at the node that we're on. And if so, if we have that for every single node in the linked list, then we know that it's read the same forwards and backwards. So we'll have another while loop here, while p. We're going to say data is equal to s.pop, so we're popping the top element off of the stack that we created in the previous loop here, this s. So we're popping off that element. Again, the way stacks work is we have the first element that we encounter all the way at the bottom of the stack, and the latest element that we encounter all the way at the top. So in the case of radar, the first element that we would be popping off would be this R right here. Or in the case of ABC, the first element that we'd be popping off would be this C right here. So we're going to store the popped value of that into a variable called data, and then we're going to check whether or not the data stored at the node that we're on in the linked list, if this is not equal to the data element that we popped off of the stack, we're just going to return false, because then we know that it's not palindromic. So otherwise, we're going to move along in the list. So otherwise, we're just going to move that p pointer right along. And basically, if we don't hit that return false, then we have a palindrome, in which case we'll return true. So let's go ahead and run this to make sure that works as well. So let's see. And one thing I forgot to do in between these two while loops is I forgot to reinitialize p to be the head of the list. So I just went right into the second while loop without doing that, and basically I was getting the wrong answer. So after we go through this first list, p will be at the end of the list, and basically if we want to iterate through p, or if we want to iterate through the linked list again, we need to make sure that we set p back to point to the head of the list. So let's actually do that. So let's say p is, or rather, p is equal to self.head. So if we do that, now p is back at the head of the list. We loop through, we follow the same procedure, and this should do the trick. So indeed, we have true for radar and false for ABC. So I'm going to comment this method out here. So highlight all this, give it a comment. So there's one final method that so in this last method, let's call it method 3. The way that we're going to approach this way of solving it is we're going to have two pointers. One pointer we'll call p, which will initially point to the head of the list, and we'll have another pointer q, which will move to the back, the last node of the list. And then what we're going to do is we're going to check the data elements at each of these nodes that are being pointed to by p and q, and we're going to ask if those data elements are equal to each other. And if they are, we progress p by 1, we move q by 1 in reverse. So we keep doing that until we get to a point where p and q either meet or essentially can't move any further without crossing. So let's actually code that up, and I think that will become a little bit more clear as we go along here. So we're going to initially set, let's say, pointers p is equal to self.head and q is equal to self.head as well. What we're also going to do, since we have a singly linked list that we're dealing with, we want q to move backwards, but we won't have any way of knowing which way q will go. We won't have any way of storing or at least currently we don't have any way of storing the previous nodes for q. So as we move q from the front of the list to the back, what we're going to want to do is we're going to store in a list all of the previous nodes of q. So that way we have a list that we can consult, and that will sequentially store all of the nodes. And basically we can just refer to that list to figure out where is the previous node for q. So let me write that out, and I think it will become a little bit more clear as we see it here. So we'll set this list previous equal to an empty list, and this will store all of the previous nodes of the node of the pointer q. So we'll be at the end of the list there, and we want to figure out how do we go back. And previous, this list is going to tell us how to go back. So we'll see how that actually works. So okay, so what we're going to do first is we're going to let's move q all the way to the end of the list. That's the first thing that we can do. So let's set a counter I is equal to 0, and we'll say while q. So while q is not null, we'll move it all the way to the back of the list. And while we're doing this, we're going to append all of the nodes that we encounter. So we're going to append q, and then we're going to move q along the list. So q is equal to q.next, and then we're going to increment the counter in this case by 1. And then what we're going to do, since at this point q is essentially 1 over where it should be, it's essentially at the null, it's at the null place, it's at the null character in the list, we're going to move it back by 1 so we can get the last node in the list. So what we're going to say is we're going to say q is equal to the previous of I minus 1. So let's actually just print that out. Let's figure out what we have so far. Let's print out q.data and see what we have. So I'm going to write that and give it a run. So in the case where we have the string radar, the last string, the last data element of that list is radar. And then for the second string that we feed in, the second list that we feed in rather, the final node with a data element, in that case is c, because we had a string abc. So we have the last node in the linked list that is not null. So we've got that. That's essentially what q has. So now what we're going to do is we're going to, let's define another count variable, which we'll set equal to 1 in this case, because we want an offset by 1. And the reason we want that is because we're going to essentially have the pointers at their respective locations. So again, remember p is at the beginning of the list, it's at the head of the list, and now q we have pointing to the last node of the list, the last valid node that's not null in the list. And what we're going to do is essentially we're going to move them to the middle of the list. And as long as they don't cross, we're going to check what the data elements stored at those nodes are. And if they're equal, we keep going. And if they're not equal, we know we don't have a palindrome. Let's go ahead and do that. So what we're going to do is we're going to say while count is less than or equal to I divided by 2 plus 1. So that's offset by 1. We're dividing I, which again is in this case, the length of the list. So we're dividing that by 2 and then adding 1 for an offset. And we're going to move those pointers p and q closer and closer together. So then what we're going to do is we're going to check if the previous of minus count.data is not equal to p.data, then we're going to return false. So this might not be super clear as to why this line works. So in order for us to figure out why that works, let me actually comment this out here. Let me actually describe a little bit what I'm doing. So we have this variable previous, and if I say previous of 0.data, if I want to print this out, let's see what we get here. So if I print out this thing, I'm going to get, for the first string, radar, I'm going to get R, and then for the next one, it's A. So let's see what happens when I replace that 0 with a 1. So I'll go ahead and write that, save it again. So again, the second node, the second data component of the second node in radar is A. The second one is B. So ABC, that's the second data element of the second string. So essentially this is storing, this previous list is storing all of the nodes that we have so far, and I'm just accessing each of those nodes, and then I'm telling it, give me the data stored at each of those nodes by asking for .data. So if, in Python, if you say, if I want the last element of a list in this case, then you can give it a minus index. So in this case, if I do this, let's see what happens. Let me write that and run it. For radar, it's a little bit hard to see, but this is actually the last node in the linked list for radar. It's the last R that we encounter. And then it's a little bit easier to see for ABC. This is the last node in the ABC linked list. So I'm getting the last node, the last data element stored at that node in either linked list. So really what I'm doing here, just to uncomment this, I'm going through and I'm checking if the last element, so essentially the last node, the data element of that last node, if that's not equal to the node that we're currently on, so the current node that we're on for P, then we know that we have a mismatch, and that way we just return false because it's not a palindrome. Otherwise, we're just going to move along in that list. So we're going to say P is equal to P dot next, and we're going to increment count by 1. And then if we get through that loop without any problems, we should have a palindrome. So let's return true in that case. So let's go ahead and run this just to make sure this works. So indeed we have true for radar and false for ABC. So this one is a little bit more, I don't know, nuanced, I guess. It's a little bit more involved in terms of what's going on. Specifically, this line might be a little bit confusing to follow. I hope that the explanation of what was going on with accessing these elements was clear. If not, please let me know in the comments below. If you have any questions or comments about any of these other methods as well, please don't hesitate to ask in the comments as well. So that'll pretty much do it for this video. If you have any other questions or comments about linked lists or anything in this video, leave them below. Thanks again for watching and have a great day. Bye-bye.